All right, this is section 2.2, linear equations. And so the first thing is linear equations can be written in the form ax plus b equals 0. And then the second thing is says that you can add or subtract or multiply by any number, except you cannot multiply by 0. So those are the rules that we use for solving equations. Let's solve a couple. So I'm going to start by looking at number 2, which says 7/3 times the quantity 2m minus 1 equals 2/5 times the quantity 4 minus 3m plus 1/5 m. And so the properties allow us to multiply by any number on both sides as long as it's not 0. And so to get rid of the fractions, I'm going to multiply by the common denominator on both sides. So on the left, I'm going to multiply by 15. And on the right, I am going to multiply by 15. Notice on the left, when I multiply 15 times 7/3 times 2m minus 1, I can actually multiply the 15 times 7/3 first. On the right-hand side, though, because I have the term separated with a plus, then I have to distribute. So I'll have to multiply 15 times 2/5 times 4 minus 3m, and then 15 times 1/5 m. Okay, so when I multiply 15 times 7/3, I can reduce the 3 and the 15 by 3. That'll be a 1 and a 5. So I have 5. And I still haven't multiplied times 2m minus 1, so I'll do that on the next step. 15 times 2/5 I can reduce by 5. This will become a 1 and a 3. And then 3 times 2 is 6. And I still have not distributed, so that's going to stay. Plus 15 times 1/5 I can reduce by 5, and I get 3m. Okay, so now I'm going to distribute. 5 times 2m minus 1 is 10m minus 5 equals... is that right? Let's see. 3 and 5. Oh, 5 times 7 is 35. So I'm distributing 35. I'm sorry about that. So it was a 5, and then 5 times 7 is 35. So this is 70m. Whoa, they're kind of big. Minus 35 equals 6 times 4 is 24 minus 18m plus 3m. Okay, I'm going to combine these m's on the right-hand side. So this will be 70m minus 35, I'm sorry. Can't read my writing. Equals 24 minus 13m. I like to take care of my m's first, so I'm going to add 13m here. Notice that the way I use the addition, that is that I can add anything, is to cancel numbers that are being added or subtracted. So I have now 83m minus 35 equals 24. And I'm going to add 35. Right, so the 35 is being subtracted, so I add 35 to make it a 0. So I have 83m equals, 24 plus 35 is 59. And then I'm going to divide by 83, and notice the difference, right? I divide here, I don't subtract, and that's because if I subtract, I have to subtract 83m. I can't really subtract 83m minus 83. But if I divide, that'll be a 1m equals 59 over 83. Okay, assuming I did everything right, that should be my answer. And of course, if I wanted to check if that's the right answer, if I did get the right answer, I would have to plug it in place of m and double check to make sure I got the same thing on both sides. It's a little bit long to do that, so I'm not going to do it. Let's try number 3. So number 3, it says solve 3x minus 4y equals 12 for y. And first I have to identify what my variable I'm solving for is. Notice that's different from these where you only have a single variable. Here, I need to check which variable I'm solving for y. So I need to isolate y. I'm going to do the same thing, use the same principles. I'm first going to subtract 3x. Careful, 12 minus 3x is just 12 minus 3x. This is negative 4y equals 12 minus 3x. And some people like to write the minus 3x first. Does not matter, whichever order. And then divide by negative 4. When you divide by negative 4, you're actually dividing each of these by negative 4. So you get y equals negative 3 over negative 4 is 3/4 x, plus 12 divided by negative 4 is minus 3. And there's my answer. Okay? All right. Let's do solving using the graph. The graphs of f of x and g of x. Okay, so remember when we're solving, just like up here, if we were to solve an equation, you're solving for x or the variable. Same thing here. So f of x equals g of x That means where are they equal? And you can actually find that real easy by checking to see where they cross. Yeah. So notice they're not equal like at x equals -4. One is up there, the other one's down here. But here, at x equals 4, they're both at y equals 1. Okay? How do we answer? Usually when you have a graph like that, you would answer the point. But here, we're solving for x. So that means we find x equals 4. Okay? Notice you're not solving a system of equations. A system, you answer the coordinates of the point. Here, you're solving a single equation, so you're only solving for x. Okay, I'll let you do number 7. We'll see it in class. Let's start number 8. So number 8 says approximately 4.8% of cancer cases diagnosed are skin cancer. Find a formula f of x for a function that computes the number of people who have skin cancer among x cancer cases. So the number of people who have skin cancer is 4.8% of cancer, right? And all you're going to do is just write that statement as an equation. The number of people that have skin cancer, which we were told to call f of x, equals 4.8% of x cancer cases. So how do we write that? Well, we can't use the percent as it is. We need to write it as a decimal, so it's going to be 0.048x. Okay, and then for B, if there are 76,000 cases of skin cancer diagnosed, find the total number of cancer cases. Okay, so I'm going to leave that to you. My advice on that is check what does that 76,000 represent, because you have f of x and you have x. Does 76,000 represent f of x, or does it represent x? And just go back and read and see what does x represent and what does f of x represent. And you only need to know one of them, because that means the other one's the other one. Okay, so I'm going to let you think about that one on your own. All right. Let's go on to 2.3, linear inequalities. And these have the same rules, except if you multiply or divide by a negative number, you have to switch the inequality around. And linear inequality is same as linear equation, except that you don't have an equals, you have some inequality symbol. Okay, any one of the 4 inequalities that we have. Okay, so let's try number 3. And number 2 and number 1 are really the same as the equations, but number 3 looks a little different because we have two separate inequality symbols. And the way you work those is, because you have two separate inequality symbols, that separates your statement into 1, 2, 3 parts. And all you do is just make sure you do whatever you do to the 3 parts. So first I'm going to distribute the -2. Notice that's just distributing in the middle. It's not doing anything to the 3 parts. And so my 3 parts, when I simplify, -8 minus 5 is -13. Okay, so now I'm going to start solving. So first I'm going to add 13. Notice I concentrate on the x part right there. I need to add 13. So I'm going to add 13 to the middle portion, to the right-hand side, and to the left-hand side. Okay, 3 places. This will be a less than or equal to -2, x is less than 18. And then I'm going to divide by -2, but I have to do that on all 3 parts. Remember, when you multiply or divide by a negative, you have to switch the inequalities. So they're just going to switch around like so. But then you just do everything, whatever it says. A divided by -2 is -4, is greater than or equal to x, is greater than or equal to -9. Okay? And notice that -4 is greater than -9, so those inequalities symbols are pointing in the right direction. All right. And we can write this in interval notation. Be careful, because the numbers are written in reverse order. That means the -9 on the number line is actually to the left of the -4. All right. And an inequality. So let's try number 5. So it says solve f of x equals g of x. We know how to do that already. Check to see where they intersect. Remember, you can only say x equals. Oops, maybe I shouldn't write an equals. X equals -1. Solve f of x is greater than g of x. All right, so where's f of x greater than g of x? That means where's the graph of f greater than the or higher than the graph of g? So if we read from left to right, here g, this is g and this is f. Here f is higher. It's higher, it's higher, it's higher. Right there, they change place, and now g is higher after that. So you want to answer only where f is higher. So f is higher over here. I'm going to shade it where f is higher with blue. F is higher, all those values of x. So from negative infinity to negative 1. And it doesn't say to write an interval notation. Higher. So at negative 1 they're equal, so I can't include the negative 1. It doesn't say to write interval notation, so we could have answered x is less than negative 1. X is less than negative 1. Yeah? And that they represent, of course, the same thing. Right? Okay. And we'll do the other two in class. Let's do one of these. Negative x plus 1 is less than 2. So we check to see here's negative x plus 1. And because negative x plus 1 is a value of y, then we're checking to see where's y equals 2. Here it is right there. Y equals 2 all along there. So where's negative x plus 1 less than 2 means where does it fall below 2? Right there. Okay. So all those values of x. So from negative 1 to positive infinity. And because it's not equal to, it only says less than, then we would put a not include negative 1. Notice if it had an equals, then we would include that endpoint. Okay. We'll leave the other two for class. You know what, let's do this one. Where is it greater than or equal to 2? Well, over here. From negative infinity to, where's the negative 1? I'm sorry. Negative 1. And we are including the negative 1 because that says include where it's equal to 2. All right, I'll let you finish the other ones here. Don't forget to do all of these. We'll do these in class, I'm sorry. So you don't have to do them on your own. We'll see them in class and we'll work them out at that time for both sections. All right, I'm going to stop here. So we'll only have one video for sections 2.2 and 2.3.